Today we are going to talk about exceptions. The English word exception means in German Ausnahme. Exceptions are situations in your code where something critical has happened and the task that you currently execute doesn't make sense to continue it anymore. Maybe the user has entered a string, you want to convert this string into a number, but the input of the user is invalid. That's an exceptional case. You are assuming that a certain file is present, you want to open this file, and for whatever reason, the operating system tells your code, you currently cannot open this file because it might be locked by another user. That's an exceptional case. In all these situations, exceptions are thrown. And today we will learn basics about these exceptions, how you can throw them yourself, how they are processed, and how the system uses exceptions to tell you about exceptional cases. Now, this sample code that you see here contains lots of tiny little samples. And every single sample teaches you one aspect of exceptions. You can try every single sample by uncommenting the correct method call. So if we want to try the first example, we simply call this method. And if you want to take a look at the second example, simply comment the first line, uncomment the next line, and you can try it. I will not try every single example because they are pretty self-explanatory. I will just show you the code. I will walk you through the code so you understand what's going on. So let's get started. The first thing that I would like to discuss with you is how to throw exceptions explicitly. We have done that before, and you have seen this code before. This throw new not implemented exception. The statement throw essentially does something similar as the return statement. The return statement stops the execution of the current method and returns to the caller. The throw statement does essentially the same. It stops the execution of the method and returns to the caller. However, it does not return a result value. So if you have a method that needs to return, let's say, an integer, with return you have to specify the integer. But at a throw statement, you are essentially saying something exceptional has happened. I don't have a result for you. Dear caller, you have to handle this exceptional situation for me. That is what the throw statement is all about. After the throw statement that you see here, you always get an exception type. And there are many different exception types. I added a link here to the code that you can follow if you want. And here you get a list of commonly used exceptions, like index out of range exception, invalid operation exception, argument null exception, and so on. I ask you as a homework, when you do your homework, you will get an exercise today, to take a look at this list of common exceptions and make yourself familiar with it. You always have to throw the correct exception. So this throw statement is like a red emergency button. In your code, you can press this button and you can say, stop it. I can't continue anymore. Something exceptional has happened. This is when you use a throw statement. Good? Clear? Good. Now, throws have a very special, let's say, superpower. They can bubble up the call tree. What do I mean with that? Imagine that you have a method, it's called here call level 3. And for whatever reason, this method throws an exception. In this case, it throws an application exception, which is just a generic exception. The application has run into an exceptional case. You can specify a description of the exception here as a parameter. Now, if call level 3 throws this exception, the control flow will return to call level 2 because here, see, call level 3 is called. However, call level 3, as you can see here, does not, we say, handle, or the correct term would be catch the exception. So in this case, the exception is thrown in level 3, but it will also immediately terminate level 2. Only if you see something like this, and this is new, you probably have not seen this, at least some of you, a try-catch block, then the exception is handled. You see, here we have the application exception, and down here we have the catch exception. Exception is the general term, the base class of all exceptions. So if you write catch exception, you are catching, handling all exception types. So what's happening in this program? If we enter call level 1, here we call level 2. Now in level 2, here we call level 3, here. In call level 3, we have the application exception. Okay, here something critical happens. I will use a different color, let's use blue here. Because of the exception, call level 3 is terminated. Call level 2 does not have a try-catch block. So call level 2 is also terminated. Now it's getting interesting because in call level 1, we know that this call threw an exception, but we have a catch statement. So because we have the exception, we immediately enter the catch statement. Get it? No? Okay. We will take a look. Let me show you something. Let's say console write line before and console write line after. And then I am going to uncomment this one and run this in the debugger. Let me, oh, I forgot to set a breakpoint here. Good. The debugger is coming up. Hopefully it will stop here. Give me a second, or give the debugger a second. Yep, my laptop sometimes needs a bit, you know that in the morning we're not awake. So here we are. See, I called call level 1 and we are currently here in this statement. Console write line before. This is executed, everything is fine. Now we enter call level 2. I jump into call level 2, you see? Take a look at the call stack. I will make this one a little bit larger so you see it better, call stack. And here. We started at call level 1, now we are at call level 2. Here. Now we enter call level 3. Take a look at the call stack. We are now call level 1, entered call level 2, entered call level 3. So we are 3 levels deep into the method calls. Now please use your imagination. Of course, call level 3 would not just contain a single throw statement in real life. You would have some loops, some if conditions, some code that you wrote. And at some situation in this code, you say something bad has happened. An exceptional situation. So you throw an exception. Let's take a look what's happening next. This throw statement immediately jumps into the exception handler in call level 1. So we jumped out of call level 3 because of the exception. We jumped out of call level 2 because it doesn't contain any catch clause. We enter this catch clause because an exception was thrown. And please note that this statement here was not executed. The execution flow was terminated because we had an exception here in call level 2, and the rest of the statements inside of the try block is no longer executed. The system says emergency exit, and it will only continue at the next exception handler. So here you can take a look at the exception and, for instance, print the exception message, as you can see here on the screen, for logging purposes. Got it? Is it now clearer? A little bit. We have more examples. Don't worry. We will practice that. But you get the idea, right? It's really useful. You do not need to return a Boolean value where you indicate success or not success. You simply throw an exception and the system will automatically enter the catch clause. Make sense? Yep. Good. Very good. So let's take a look at additional examples. And we are going to practice the whole thing afterwards. Here you see another type of exception. Before we had the application exception. Now we have exceptions which are related to invalid arguments. For instance here, I get an optional integer value as an argument. Maybe this parameter must not be 0, or null is the better term here. I can check whether the value is 0, and if it is null. If it is null, we throw an argument null exception. You see? I'm not using an invalid operation exception here, or not implemented exception. I'm using the correct exception type. There are exception types for every single exceptional situation. The type describes the kind of exceptional situation that you currently have. So this would be an argument null exception, very frequently used. Please remember that. Question.
What does the name of while doing the...
That's the next thing that I wanted to cover. The argument null exception requires a single argument, and this argument is the name of the parameter that was null. What you could do, let me show you that, you could simply use a string and say val here. You could do that. You see, the name of the argument is this one, and here you say val was null and therefore I throw the exception. But the problem if you do it like that is that if you rename this parameter, I will do that here. I will press F2 and call this one, I don't know, int param, something like this. You see, this was renamed. Everything was renamed, but what wasn't renamed? This one. And so you have an inconsistency in your code. So what you typically do is you are using the name of operator, which just gives you a string with the name of the argument. Nothing special, nothing fancy. But now if I rename val here, int parameter, something like this, this is also renamed. Does this answer your question?
Yes.
Very good question. Thank you. Now, it might happen that the value isn't null, but it has an invalid value. For instance, imagine that this function assumes that the argument must be positive or 0. Then you can say if val is lower than 0, you can throw an argument exception or an argument out of range exception. Both things exist, and it's sometimes this is more suitable, sometimes this is more suitable. That's your decision. Okay? So argument exception or argument out of range exception, and here you can say the argument val has a value which is not valid, and in this case value must be greater than 0. Sometimes you get an exception even if you don't throw. Take a look at this example here. Implicit exception. It divides the divisor divided by the dividend. Now what happens if the dividend is 0? Then you divide something through 0. What is the result of an integer division by 0? Do you know it from mathematics? Yeah.
It's not defined.
It's not defined exactly. There is no answer to this question. It's a division by 0 using the integer data type. That is important, okay? In this case, C# will automatically throw a division by 0 exception. You don't see it here. There is no throw statement anywhere in the code. But what you see here is that C# is using exceptions to indicate that you did something wrong. I can show you that if we look up here and we call this method and we pass 0 as the second argument. I can run this in the debugger. I press F5. The debugger is coming up. It's compiling. And in a second you will see that we have an exception. Here we are. Divide by 0 exception, and here you see the exception. So it can happen that certain exceptions are thrown, although you can't see a throw statement in your code. Let's take a look at the next example. I give you a second to take a look at this example, and you try to understand why this will throw an exception. I guess that many of you have made this mistake. Do you see it? Yeah?
It's like an endless loop.
Exactly, because we are in the method implicit exception 2, and we call the method implicit exception 2. So the method calls itself over and over and over and over again. That's a so-called endless recursion, and that will lead to a Stack Overflow exception. Now let me tell you something which is useful to know. It's not critical to know, but useful to know. Listen closely. You cannot catch a Stack Overflow exception. If a Stack Overflow exception happens, the program terminates. Full stop. This is a security measurement, because we'll not talk about the details, but it is possible to attack a computer program by forcing it into a Stack Overflow exception, into a Stack Overflow. If you ruin the stack, you can execute code which should not be executable. That's a security measure. Therefore, Stack Overflow exceptions cannot be caught. It's not possible. At least not in C#. Here, we have another example of an implicit exception. You allocate an array of strings, 5 strings. Now, what are the strings in this array after allocation? They are all, yeah? Null, exactly. We have 5 null references. And here I'm accessing the length property of a string which is null. Again, we have an implicit exception. The system will throw a null reference exception in such cases. Null reference exception can be caught. That is fine. Okay. Now in the framework in .NET, some of the methods throw exceptions in certain cases. Here you see int.parse. This is not a number, right? Therefore, this method will throw an exception. The other option would be to use try_parse. Try_parse will not throw an exception. It will return a Boolean value indicating whether parsing was successful or not. So in many situations in .NET you have to choose between the method which throws and the method which doesn't throw an exception. And here I have a super important guideline. Do not use to only use exceptions for exceptional conditions. Do not use exceptions for regular control flow. What I mean with that is, if you write a program where the user can type in something on the console, it is very likely that the user will screw up. it is very likely that the user types something wrong. So therefore, a wrong input is not an exceptional situation. In such a situation, you should always prefer the try method, which does not throw. Exceptions are for exceptional situations, not for situations where an error is very likely to appear. Good? And the reason is exceptions are slow. If you have a lot of exceptions in your code will be slow. Therefore, avoid exceptions if you don't need them. Let's talk a little bit more about catching exceptions. If you just want to catch all exceptions, independent of the exception type, you simply write try catch, nothing else. That's it. Catch catches all types of exceptions. That's a simple one. It's the most simple way of catching exceptions. Not the Stack Overflow exception. This will not be caught. Everything else will be caught. On the other hand, sometimes you need to access the exception details. For instance, the exception message. What was the cause of the exception? Please take a look and consciously recognize the differences between these two things here. Both options catch all exceptions, but the version on top does not give you access to the error message. You simply say, I want to catch it, I don't care what the reason of the exception is. The version down there, the version below the other, here you have a variable, I called it x, and you can access the message by using this variable. So you can print an error message on the screen. Good? Understood? Nice. You can also catch specific exceptions. Take a look at this code. Here you have a try statement, but then you have different exception handlers for different types of exceptions. If the method threw a not implemented exception, you are doing this code. If an application exception was thrown, you're executing this code. If an invalid operation exception was thrown, you're executing this code. And if none of the above was thrown, then you simply handle exceptions in general. This is typically the thing that you see at the end of all your lists of exceptions. Sometimes you need to distinguish. If this exception happened, I have to do that. If this exception happened, I have to do something else. Then you use exactly this syntax. You simply say what kind of exception, and then you handle it. If you ask yourself, well, how should I handle it? That depends on the requirements of the program that you write. In many situations, you write it on the screen or in a log file or display a friendly user message to the end user or something like this. Okay, we are nearly through. This is a kind of advanced thing. Sometimes you need it, but to be honest, you don't need it very often. So remember that it exists, but you will probably not use it quite frequently. What you can do is you can catch an exception, but you can add a so-called exception filter. You could, for instance, say, hey, catch the exception, but only catch it if the message contains the string 404. So you can add filtering. I'm not catching everything, I'm only catching this specific type of exception. You do not need to remember that. Remember that it exists, but you do not need to remember the details of the syntax. You can look it up if you need it. Yes?
What does line 168 mean?
Line 68? It simply says, I'm throwing an exception. Application exception is a generic exception. Something went wrong. And here I'm just specifying a description. You can write here whatever you want. I don't know. My spaceship exploded. And here then you can say I'm only catching exceptions related to spaceships. You can write any kind of error message. Just describe the reason for the exception. Make sense? You could even say I don't specify a string here, but then you will make your life pretty complicated because, for instance, if you run this program, you will see an exception has occurred without any error message. It will be hard for you to find out what is the reason of the exception. So therefore, it is good practice to always add a description that describes to you or the user of the method what the reason of the exception was. It makes the debugging and looking for errors much easier. Make sense? Okay. The next one is important again. You absolutely have to remember this one. Sometimes you want to catch an exception. You maybe want to print something on the screen. Oh, something bad has happened. But then you want to forward the exception to your caller. And this is the throw statement here. Throw simply means, okay, I handled the exception, but now I want to continue like I didn't handle the exception. Understand what I mean? Somebody says there is an exception. You say, okay, I take a look at the exception, and then maybe decide, okay, I really don't want to handle it. Let's pretend I didn't catch it. And this process is called rethrowing. You simply say throw. That means take the exception and throw it again to the caller, like we never touched it. We simulate that the exception handler wasn't there. You will see over the next few months and so on that this situation happens pretty frequently. Currently, you might ask yourself, why should I need that? Give it time. You will see you need that. I think we have 2 more concepts left, and then I'll show you the exercise with which you can try that. The finally block. The finally block is also something which is used very frequently. Here you see try, catch, we have it already, and suddenly we have something else here. It's called finally. Finally is code that is executed independent of whether there was an exception or not. So the program flow in this case will look like this. We start with the method. We execute some code. This code will throw an exception. And therefore, we handle the exception. But then, cleaning up happens. So finally is executed even if the exception was thrown. The important thing is, if this method here would not throw an exception, the finally block is also executed. When do you need that? Imagine that you open a file here. Now, where would you close the file? Would you do it here? Close the file. If you do it here, you have a problem. Because when you throw an exception here, this code will never be executed. What you essentially would need to do, you would need to close the file here. But imagine that you have multiple of these catch handlers here. Then you would need to close the file in every single catch handler. That is very inconvenient. Essentially what you say is, whatever happens, exception or not, you must close the file. And this is exactly what finally is all about. So in our situation, we would simply say here, finally, here, kein Problem, here, you close the file. Question?
But we're catching an exception, and in this case we're catching all types of exceptions.
Yes.
Right? The code continues running after we caught it, right? Because we're not rethrowing it.
Exactly.
But does it make a difference to leave out the finally block there and put the console right line finally block executed just out of the block at the end of the try catch?
Yes, you could do that. What you could do in this situation, you could leave out the finally. That is correct. But what you could also do is something like this. And now it makes sense, right? You say, I do not want to catch the exception, but still, independent of if the exception happened or not, I need to close the file. Does it make sense?
Yeah.
Good. Again, this is something that is somewhat frequently used. You will not use it on a daily basis. The other things which were above are more important. Last concept, and then we are going to talk about the exercise. You can create your own exceptions. How can I create my own exceptions like that? I'm super sorry, but you have to know this code. This is the blueprint for the upcoming weeks. You will need to create your own exception classes. Essentially what you do is you create your own class and you derive from the base type exception. Derived classes, we had that at the beginning of this year. If you can't remember derived classes, go back and revisit the things that we did at the beginning of this year. We did that. Remember, abstract classes, abstract base classes and all this stuff. We had that. And that will also be an important topic for the upcoming weeks. So, you create a derived class from exception, and then you have to create these three constructors. If you can't remember what a constructor is, revisit what we did at the beginning of this year. We covered that. You have to create a constructor without a message where you typically type in a default error message. That's just a generic error message. What is this exception all about? You have a second exception which accepts a message. This is a description of the exception. And finally, you have an exception with a message and an inner exception. I will not tell you in details today what an inner exception is because we don't have so much time today, but this will definitely be something that we cover in the upcoming weeks. Just trust me. If I ask you to generate your own exception class, this is the code that I want to see. It is very likely that in the next Leistungsfeststellung, in the next exam, you will need to create your own exception class. And then I want to see exactly that code. You will get my material again, so you do not need to learn it by heart. You can look it up, but you need to know that something like this exists. Okay? If you have an oral exam with me, I will very likely ask you, show me how you create a custom exception class. That's a very important topic. This is everyday C#. Believe me, if you are a professional C# developer, you do that, well, maybe not on a daily basis, but at least every week or so. Yes?
Why do we have to make three constructors?
Because that's the convention in C#. The designers of C# said these are the three defined standardized ways of creating an exception. Without a message, with a message, and with a message and an inner exception. That's just a convention.
Und wenn wir das initialisieren, wie viele Parameter schreiben wir dann?
You see that directly above. You can choose. Either you say, throw my exception. You do not specify any specific error message. You can say here, this is the reason of the exception. The first one we called this constructor. This now calls this constructor. And the last constructor with the inner exception, as I said, I will not cover that today because of time constraints.
And what is with a rock crashed into the ground or something like that?
That's just, I wanted to be funny here. You can write whatever you want, anything. Just enter a reason of the problem. What is the problem? describe the problem here. If you're building software for a spaceship, you might have a spaceship crashed exception. If you're building software for driving an autonomous car, it might be I hit a pedestrian exception or whatever. Just describe the reason of the exception here.
But not two different reasons.
Yeah, this might be a very generic. Something bad happened. I don't know exactly what. And here, if you want, you can specify a more detailed exception. Okay? Generic, we'll see. You will practice it. That was the theory. I know it was a lot of theory today, but it was important theory. So now we are going to practice that. So let me show you what I have prepared for you. I've prepared a small homework for you. This homework can be found exactly here. I will send you this homework through Discord. Please spend time with this homework because exceptions will be important from now on. Essentially, what you have to do in this homework, you have to implement just two methods. Let me increase the font for you. The first method is called parse. It gets a date string and it should return a calendar date. Let me show you calendar date. Calendar date consists of year, month, and day. The specification, what you have to do in details, is laid out here in the comments section on top of the method. So essentially, you have to parse a string which gets the date in exactly that format. 2-digit day, 2 digits month, 4 digits year. The important thing for the first time in your career here, I demand certain exception types. You have to throw an argument out of range exception if the date string is empty or the date string does not have a length of 10 characters. If that happens, you have to throw this exception. If the length is correct, but the date string is syntactically invalid, maybe you don't get digits, but you get letters or something like this, then you have to throw a format exception. If the string is syntactically correct, but the date doesn't make sense, the 32nd of January, then you have to throw an invalid date exception. Get it? It's not too complicated. The algorithm is not very complicated, but you should practice throwing the correct exception types. I added a lot of automated unit tests so you can verify whether your code is correct. Just run the unit tests and you will see whether your code is correct. You have a question?
This is a question for the code. What are these three slashes and the summary? It looks like HTML code.
This here? Very good question. Maybe you have seen that before in my code. This is so-called C# XML documentation. If you write your documentation in C# using these XML tags here, then Visual Studio Code and Visual Studio will understand these commands and will format them nicely. So if you hover over with the mouse over one of your method names, it will show you a nicely formatted view of the documentation. Okay? Just give me 1 more minute and then you're done. The second class is build response. That's just a wrapper around the previous method. It receives the date string, but in this case, it must return a string. And the string should be this one if everything was okay. This one if we have an argument out of range exception. This one if we have a format exception. and this one if we have an invalidate exception. So essentially, this method has to call that method with a lot of catch exceptions, catch clauses. Got it? This is not a difficult homework, but it gives you, let's say, a starting point for understanding and practicing exceptions. Okay? Good. That was the theory for today.